I want to do just one more restricted domain example. And this one doesn't involve trigonometry, but it's instructive nevertheless. So let's let f(x) equal x minus 1 squared plus 3. We want to find a restricted domain on which f is 1 to 1, and then find the inverse of f on that domain. So first of all, let's convince ourselves that this function isn't already one-to-one. This is a quadratic function, which means it's going to be a parabola. If you know this form of quadratic equation, you can see that it's going to have a vertex of 1 comma 3. That's something you should know from a previous algebra course, that in general y equals x minus h squared plus k has vertex hk, like that. So uh, in this case, the vertex comes out to 1, 3. Otherwise, it's just going to be a parabola that looks like this. So it's not too difficult to realize that this parabola certainly fails the horizontal line test, and therefore it's not one-to-one, and therefore it's not invertible. So what we have to do is find a restricted domain on which it is invertible. The natural way to do this is just look for the portion of the function that is increasing. You could also pick the portion that's decreasing. It doesn't actually make any difference. The point is that function, if you recall from an earlier discussion, a function is one-to-one if it is monotone, where monotone means that it's either entirely increasing or entirely decreasing. So we're just going to pick one side of this function. I'll put this in a thicker line like this, and once the domain is restricted to just that side of the parabola, you can easily see that it does in fact pass the horizontal line test, and that the horizontal lines now only intersect that half of the parabola in one point. So let's restrict the domain. Make that a little smaller. We're going to restrict the domain to the interval 1 infinity, because we can go as far to the right as we want and still have this be a one-to-one function. It's just that we have to stop moving to the left once we get to that vertex. Okay, so now all we have to do is solve for x in terms of y, and then switch y and x. So let's write out y equals x minus 1 squared plus 3, and now I'm just going to zip through a little algebra. Okay, so we've gotten to this point, and we can't keep this plus or minus in, because what you can see is that if I reflect that parabola over this line, that's going to give us that would give us the parabola. It looks like this, and of course that would fail the vertical line test, so it's not a function. That's precisely why we restricted the domain. So we're only going to consider that really thick part of the parabola, which maybe I'll highlight in green just so you can see what part of the parabola we're considering. So we're going to draw in the reflection, and it looks like this. So that's where f minus 1 is, or sorry, f inverse. In fact, let me draw that in a different color so it can be more easily seen. There it is. That's f inverse, that half of a parabola. And what we can see is that we don't want to look at the lower part, which would be the part that's less than 1. We want the part that's greater than 1. So I'm going to eliminate the minus sign in this y equals 1 plus or minus square root of x minus 3, because I want to go up and not down to find that branch of the parabola. So this is going to be the inverse function will be 1 plus the square root of x minus 3. And by the way, you can see what its domain is just by looking at the range of the original function. You can see that even for the restricted domain half of the parabola, we can see that its range goes from a low value of 3 all the way up to infinity. So that means that the domain of the inverse function is going to be 3 to infinity, which makes perfect sense because we have an x minus 3 under the square root sign. We know we can't put any x value smaller than 3 in there, so that's going to give us a restricted domain of that's going to give us a domain for the inverse function of 3 to infinity. So just to clarify, the question was to find the inverse of the function on a restricted domain. This is, in fact, the answer to that question.